What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to look at lesson 5.4, equilateral and isosceles triangles. We're going to talk a lot about the base angles theorem, the converse of base angles theorem, and to be able to use isosceles and equilateral triangles. The first thing we're going to write down are all of our vocabulary terms, so let's start with these. In an isosceles triangle, the two congruent sides are called legs, and the third side is called the base. This angle formed by the legs is called the vertex angle, and the other two angles are the base angles. So what we're going to do is we'll show a picture here in just a moment, but let's go and make sure we have all this information written down. And then as you're done, you can click play to continue on with the video. All right, here's our base angles theorem and then the converse of that. If two sides of a triangle are congruent, then the angles opposite them are congruent. So that just means here's a side like AB, and AC is also congruent to that. That means angle B is congruent to angle C, okay? Here is just a picture of what the legs look like, and here is the base here at the bottom. But just so you know, that's how it works. So this is an isosceles triangle because two of the sides are matching, which means two of the angles will also match. So for example, the converse base angles theorem just states if B is equal to C, then AB would be equal to AC because angle C is across from AB and angle B is across from AC. Take time now to just let this soak in for a moment, and then when you're ready to try an example, let's keep going. Okay, in triangle DEF, DE is congruent to DF, name two congruent angles. According to that base angles theorem, I know that angle F is right across from DE, and I know angle E is across from DF, so angle F is congruent to angle E. Okay? Copy and complete the statement. If HG, which is here, is equal to HK, then what angle is equal to the other one? Well, looking across from it, we can say that angle maybe K, which is technically two different angles, so we have to be very specific about that. So let's maybe say this is HKG, because that encompasses angle K right here, is congruent to angle G, right? Which would be right here, okay? Let's look at the next two. If KHJ is congruent to KJH, then what happens here? So KHJ, which would be this angle, is congruent to KJH, then what sides are equal to the other? Well, this is my converse of the base angles theorem. Across from angle H is line KJ, and across from angle J is line KH. So I know KH and KJ are congruent. Make sure we put our little line notation on top. Okay? Now we have something called corollary. So corollary to the base angles theorem. This just means when you add on to this. If a triangle is equilateral, then it's equiangular, which just means angles are all the same. The corollary to the converse of the base angles theorem just states if a triangle is equiangular, then it is equilateral. Just means if all the angles are the same, then all the sides must be the same. So what we're going to do now is try a few examples. Find the measures of angle P, Q, and R. Okay. What we know is since we see that there are three congruent sides, we know that we can use that corollary. If a triangle is equilateral, then it's equiangular. Just means that all the angles are going to be the same. So P will match R, will match Q. So what I do is we can think about these as x's. They are unknown. That could essentially mean 3x is equal to 180, right? When you divide by 3, x is equal to 60. So angle P is 60 degrees, so is angle R, and so is angle Q. The next example we have is talking about the converse of that. So when you look at equal angles, that means all of your sides will be equal. So if all three of these angles are matching, that means all three of the sides should be matching. And right here, it's notated that TU is 5. So that means ST is 5, and so is SU. So ST is equal to 5. The last little bit, we're going to use a little bit of algebra skills here. So it says, find the value of x and y in the diagram. One thing you want to keep in mind is this first one, if you want to draw it all by itself, sometimes it helps drawing it separately. So K, L, and N all have the same angles, which means they're all going to have the same sides. And right now, one of the sides is listed as 4, which means all sides are the 4. So y is equal to 4. Okay? The last little piece we have is x. And again, you might want to consider drawing these separately. Okay? We have N, L, and M. And then this side says x plus 1. Okay? Here we have something different though, because we don't have a lot of information, but we do know that Ln is equal to NL. And as we stated before, that's going to be equal to 4. So using the knowledge of equal angles, notice how angle M is across from 4 and angle N is across from x plus 1. So that means 4 and x plus 1. I apologize for all the interruptions. So 4 is equal to x plus 1 because angle N is across from x plus 1 and angle M is across from 4. That just means x has to be equal to 3. Our final example is coming from this one. It says in the lifeguard tower, PS is congruent to QR and QPS is congruent to PQR. Go ahead and take a moment to look at those few options. And what we're going to do now is try to explain how to prove that angle QPS is congruent to PQR and explain why PQT is an isosceles triangle. One thing we want to start off with is what our givens are. So we are given that PS is equal to QR and angle QPS is congruent to angle PQR. Okay, here is PS. Here is QR. QPS is here, and PQR is here. Okay. One thing we also might want to say is because PQ is down here, it is looking like it's across from some congruent angles. We can also maybe think about how PQ is congruent to QP. So if we wanted to use PQ in the triangle, sorry again for all the interruptions, think about these as two separate triangles. And right now we're saying that PQR and QPS are matching, and these sides are matching as well. Notice that P and Q are sharing a side, so that means P and Q should also be matching. Okay, so we can say PQ is congruent to QP by using the reflexive property. So we can then state that we have our side, angle, side, because we proved that PS is equal to QR, and then we have our angles here that are matching as well. Now we want to talk about why could PQT be an isosceles triangle. If you look at PQT, it looks like this all by itself. Here's P, here's Q. We know that those match. Because we have two matching angles, we should have two matching sides. Okay, so that means probably if we look at angle P is across from QT, so QT is congruent to angle Q is across from PT, PT. So that would mean it's isosceles because it's two matching sides due to the two matching angles. That will conclude our notes for today for lesson 5.4, equilateral and isosceles triangles. Thanks so much for tuning in. If this video helped you at all, give it a thumbs up and hope you join us